Welcome all. I am A.R. Manjula Devi, Assistant Professor in Department of EEE at JJ College of Engineering and Technology, Tiruchi. Now I am going to present a video lecture on Basic Electrical and Electronics Engineering. Subject code is BE 3251. Now we are going to discuss about error detection and correction. The transmitter transfers the data to the receiver. During the transmission, error will occur at some time. The identification and detection of this error is known as error detection. The rectification of this error is known as error correction. The network must be able to transfer the data from one device to another with complete accuracy. The data can be corrupted during the transmission. Now consider this diagram. The message is transmitted from one person and received by another person. While receiving the data is corrupted because the external noise interact with the data during transmission. For reliable communication, error must be detected and corrected. Before going to error detection, we are going to discuss about the types of error. Basically, there are three types of error that occur while transferring the data. They are single bit error, multi-bit error, and burst error. Definition of single bit error. A single bit error occur only one bit of data unit, that is 1 byte, is altered during transmission. For example, the transmitter data is 000010 and it is received as 00001010. Here only the fifth bit is flipped from 0 to 1. Hence, it is known as single bit error. Single bit errors are the least likely types of error in serial data transmission because the noise must have a very short duration, which is very rare. However, this kind of error can happen in parallel transmission. This is the example of single bit errors. If the data is sent at 1 megabyte per second, then each bit lasts only 1 microsecond. For a single bit error to occur, the noise must have duration of only 1 microsecond, which is very rare. Then we are moving to multi-bit error. A multi-bit error happens when two or more bits in a data unit are corrupted or changed during transmission. For example, the transmitting data is 0 1 0 0 0 0 1 0 and the receiving data is 0 0 0 0 1 0 1 0. Here several bits have been altered, which was in second and fifth place. Then we are going to see about burst error. A burst error is nothing but is a group of consecutive bits that are corrupted during transmission. The length of the burst is measured from the first corrupted bit to the last corrupted bit, even if some bits is in between are corrupted. In this example, the burst error might span from 3rd to 7th bit. The term burst error means that 2 or more bits in the data unit have changed from 1 to 0 or from 0 to 1. Now we are getting into our topic error detection. Error detection can be simply set as identification and detection of errors in the transmitted data. The received data should be verified whether it is corrupt or not without a copy of the original message. It uses the concept of redundancy. Redundancy is the process of adding extra bits for detecting errors at the destination. Working of redundancy in data detection. The generating function generates a extra bit and combines with data. The adding of these extra bits is known as redundancy check. The data and redundancy check is sent from sender to the receiver. The checking function in the receiver verifies the data and redundancy check if the data was not changed and there is no error in the data, then it is accepted. If there are errors in the data, then the message is rejected. There are 4 types of redundancy check in the data communication. They are VRC, vertical redundancy check; LRC, longitudinal redundancy check; CRC, cyclic redundancy check; and checksum. VRC, it is nothing but adding a parity bit with the data and checking the data in the receiver within the total numbers of ones, either it is even or odd. In this example, using even parity generator, the parity bit 1 is generated and it is combined with the data. The combined data is sent to the receiver. The checking function in the receiver checks whether the total number of ones is even. VRC can detect single bit error. It can detect burst error only if the total number of error is odd. Longitudinal redundancy check. LRC is used to check the long data in its directions of the movement. It increases the likelihood of detection burst errors. If 2 bits in one data unit are damaged and 2 bits in exactly the same position in another data unit are also damaged, the LRC checker will not detect an error. This is the diagram of VRC and LRC. Kindly go through it. Cyclic redundancy check. In cyclic redundancy check, the first bit of the data is transferred to the last and the remaining bits are moved one step ahead. This forms a cycle and hence called as cyclic redundancy check. Given a k-bit frame or message, the transmitter generates an n-bit sequence known as a frame check sequence, so that the resulting frame consisting of k plus n bits is exactly divisible by some predetermined number. The receiver then divides the incoming frame by the same number, and if there is no remainder, assume that there was no error. It is a normal binary division. It is basic polynomial equation with highest power of 7. X power 7 plus x power 5 plus x square plus x plus 1. In this polynomial function, 1 is used for the exceeding terms and 0 is used for the non-existing terms. Next, we are going to see about checksum. The n bits is added with k number of section in the data and sent to the receiver. The receiver checks if there is all 1, then accept, otherwise it is rejected. At the center, the unit is divided into k section, each of n bits. All sections are added together using 1's complement to get the sum. The sum is complemented and become the checksum. The checksum is sent with the data. At the receiver, the unit is divided into k sections, each of n bits. All sections are added together using 1's complement to get the sum. The sum is complemented. If the result is 0, the data are accepted, otherwise they are rejected. The checksum detects all errors involving an odd number of bits. It detects more errors involving an even number of bits. If one or more bits of a segment are damaged and the corresponding bits or bits of the opposite value in a second segment are also damaged, the sum of those columns will not change and the receiver will not detect a problem. If there are feedback and comments, kindly let me know at manjuladeviar@jjcet.ac.in. Thank you.